will wait.
Sir, actually, the students are joining right now. So within like at sharp 6:30, we can start the.
Yeah, I'm ready anytime.
Thanks. Sir, hello, sir. So it's morning that time, sir. There,
Yes, yep. It's morning for me, so this is works out well like that. Start the day with this.
sir. So how's your journey like in Hugging Face? Like as
It's
a
great. Yeah, I've been with the company for a little over a year now, and I mean, since I've been here, there's been just so many amazing developments. I think when I joined, the Dolly Mini a year ago or so was blowing up, the text to image, and then since then, this last 6 months, the large language models and all that stuff has been really exciting. So yeah, no, it's a great time. Well, hey,
so,
will you
sir.
be recording this? It doesn't matter to me. I'm just curious.
Yes, sir. It will be
Okay.
saved in the YouTube channel also.
Okay,
This will be saved.
perfect. Okay. Sounds good.
So hello everyone. We will be starting the meet at sharp 6:30. It's 6:28 now. So join as soon as possible within 2 minutes. We will be resuming the meet. So I hope everyone has joined, and those who want to join can join the meet from now. So good evening, everyone. Myself Ayush Kumar Dalai from NIT Raulkela ML4E, and welcome to today's episode 3 of the AI Age Expert Perspectives with all Rajiv Shah, MLE from Hogging Face, Adjunct Assistant Professor of University of Illinois at Chicago, Principal Data Scientist at DataRobot, Senior Data Scientist at Caterpillar Inc., and the list goes on. So let's welcome Rajiv sir to deliver his views on LLM evolution. So today we will dive into the world of LLM evolution, starting from exploring the automated suites like LM Harness, unveiling the chartboard arena LO rankings with IMSOR organization, embracing the GPT-4's cost-effective evolution, and unraveling the intricacies of generative AI in prompt creation and tokenization. So over to you, sir.
All right. Thanks so much for having me. Let me get my screen shared here. Oh no. Error has occurred. I got an error screen sharing. I should have tried that earlier. Hold on. Let's try this. All right. Can you confirm you can see my slide up? Okay, excellent. All right. Thanks so much. So, hey, thank you all for kind of joining today. A little background on myself, a machine learning engineer with Hugging Face. Most of what I do is I talk to businesses, to enterprises that are trying to use all these technologies. So I work more on not the research side, but more on like how do we actually use these technologies to get some business results. The other part is I like to communicate, share out the results. For many years, I used to do written blogs. Over the last kind of year and a half or so, I've moved a lot to video simply because that's how people learn now. So I have a YouTube channel which has a little bit, but I spend most of my time on either TikTok or Instagram making lots of short form videos on fun topics like a bunch of the things that I cover here you can find in TikToks that I've created a while ago. So that's another avenue if you're kind of interested in all of this. So what I want to talk about today is evaluating LLMs. This is the first time I'm kind of giving this talk, so it might be a little bit rough. I have no idea how long it'll even take me to get through it. But this really comes out of a desire to better understand which large language model to use. If you look in the world we have today, let me actually go and see this. If you look at the world, if you look at all the different LLMs we have, it's just a confusing mess. There's so many that we could choose from. So what I want to do is try to see if we can help ourselves think through what are the best ways to go on this. And it's a nice slide change. So I'll start off with a little bit of background on large language models. I'm assuming all of you are kind of up to speed on that. We'll spend most of our time talking about different evaluation approaches, and then some time at the end talking about hallucinations, which is a common problem. I like to keep this interactive. Don't feel like you just have to sit there and listen. So feel free to kind of pipe up and ask questions directly. I'll stop sometimes, pause and see if there's questions, or if you're shyer, you can just put it in the group chat and then somebody else can voice it and let me know that there's a question in the chat as well. Okay, I need the energy from all of you to do this. It's hard to talk to just a blank wall like that. All right. Everyone with me so far then?
Yes, Rajiv.
Okay, excellent. Excellent. Thanks for the feedback. I like the feedback going through because I can't see your faces or anything. So let's talk a little bit about how we got here. Right, a couple of years ago, OpenAI released GPT-2, which at the time helps you predict the next word or token. And you could do little fun things like this, just like the same games we play on our phones where you could do the next complete, make silly sentences like that. It seemed interesting, but wasn't sure exactly what the practical point of this was. But then at this point, it was probably about a year and a half ago or so, the GitHub Copilot came out, which gave us the ability to take that same kind of predictions of the next word, next token, but apply it to code. And hopefully all of you have been exposed and been able to try it out like that, right? It's an amazing tool. Software developers for the most part like it. It improves their productivity. Being able to use a tool like this, I talked to lots of enterprises that are trying to get this thing into production on their code so their folks can kind of have a better experience like that. And this is one of the best kind of early use cases of these models. It's really paid off. Now, we come all the way to modern times. You have newer models like GPT-4. And this was a recent story I found where people use GPT-4 to write pitch decks. And the pitch decks were rated higher than the ones created by humans. And it just gives you a sense of like how far these models have gone, that they can structure and organize and create persuasive writing that's even better than what people can do. Now, beyond kind of those use cases, we're also finding another strong use of these models is combining these models with traditional information retrieval techniques, traditional ways of searching, finding information. So when we do some type of question answer, for example, we can use vector databases, a vector search to identify what are the most relevant documents, but then take advantage of a large language model. In this case, this is an OpenAI model, to then synthesize, take all those different pieces together, formulate it into one coherent paragraph. And I always like this example because it answers the question, it pulls from 3 different sources, but it also lets you see which of the sources it does. So again, I'm hoping most of you are kind of familiar with this example. For a lot of people just getting into this field, like if you're looking for your first project, this is often something I suggest, and it's become kind of the replacement for Twitter sentiment that people used to do, 2 years ago as their first data science project like that. The last piece I like to remind people is these things aren't text only, but also multimodal. You already see a number of large language models taking into account images. Sound is going to be coming around pretty soon as well. But this on the left side was an entire advertising campaign that was created entirely with a multimodal language model. So human didn't have to do anything. And it was rated better than many of the human created advertisements. But in this competition, the one that won the best, the one that was on top, was one that was both a human and a computer working together. And I think a lot of times the way we're actually going to see these models being used in enterprises, in businesses, is as augmentation, a combination of humans working with these models. Because for the most part, and we'll talk about it later, there's a number of issues with these models that you don't necessarily want them running by yourself. All right. So at this point, hopefully, a little bit of background on LLMs. If you came to me and you said, hey, I need to pick out a large language model, I have a project, which one do I go to? Usually this is where I get my little preacher hat and stand on the thing and tell you, well, you need to think about your use case. What are you doing? Is this a model that has domain knowledge that's already sitting within one of these models, or are you going to have to actually give it out some type of information as well? And, as you do this, I'll remind you that, there's a lot of different large language models, but you also need to think about how much your use case is worth, how much you're going to invest in the solution. Because yes, you can use the fanciest, the greatest, GPT-4 model, but if you're doing a ton of predictions, if you're doing something with security or privacy, that might not be the best solution. There might be something that's smaller and cheaper that you could use instead. And so this is where you need to understand exactly why you might be choosing a certain large language model. And then once you do that, there's considerations about, model size, how big of a model should you use, the licensing. Some of these aren't available for commercial use. You might want to do some optimizing of it, distillation, quantization, all that stuff. And so that's the usual story I give to people that are selecting a large language model. But here's the reality of it. Like, if you're out there and you have to search for it, like I mentioned, there's so many large language models out there, right? Like, it's a huge field of that. Like, how can you start kind of winnowing it down and figuring out which is the best large language model for you? So let's talk about this. The one thing to keep in mind is these models all have a history. They have different architectures. They have different kind of, just like people have different genealogies and lines. These models come from different ones and have different parents, for example, and siblings along the way. And so that's one element of kind of that, how they're different. They're also different in terms of things like, what's the data that was used for them? There's some models that are entirely like AlphaCode based on code, Python, Java. Some models are entirely based on text. Some have a mixture of it, books. There's other pieces like that. So there's lots of different ways these large language models kind of have differences in themselves. You know, some of these models are updated with more recent information. Some of them have used much older information. So there's a lot of aspects of models that we can get to. But one of the common starting points for evaluating these models is because we use them for language is, why not just use traditional NLP techniques that we have for evaluating models? So take something like, right, and these are some of the traditional classic approaches we have, but take something like sentiment. We can prompt one of these large language models to do a sentiment classification. And when we do that, we find that these models do really well. I mean, in some cases, they do better than state-of-the-art models. But this is one way we can analyze and see, you know, which of the models is the best. We can do this with other NLP tools, some things like summarization, where we're measuring these models on how good is that summary based on faithfulness, coherence, and relevance, things that we can kind of judge along the way. Right. With reading comprehension, we have benchmark data sets that we can use, like trivia question answer, that we can take these models and see, you know, how well are you doing on them. So all of this allows us to think about, you know, a lot of these traditional evaluation metrics that we've had over the last 10, 20 years in the NLP space, and we could just apply them to our large language models and literally end up with kind of, you can think of it like a sentiment leaderboard. I could, you know, do a leaderboard for any of these tasks and use that. In this case, you'll see it's like the FLAN T5 and the ChatGPT models here that I'm evaluating, but there's no reason you can't do this to every large language model like that. All right. Now, so this is like the most basic way we can think about evaluating the models. I'll pause here to see if I've kind of lost everybody, or are folks with me still on this so far? Okay. Now, I like something. There's different ways you can think about language models. You can think about them like people in certain ways. And here you have Tiger and Michael Jordan that have lots of skills and capabilities. They could do a lot more than just analyzing sentiment or reading comprehension. And if you throw me into the mix here, I'd like to think if we did a sentiment analysis test, it would probably be pretty close. Maybe Michael Jordan would be a little bit better. He knows how to work people than me. Right? If you gave us a reading comprehension test, I like to think maybe I'd finish second. I mean, Tiger went to Stanford, and you know, I went to University of Nebraska, where the N stands for knowledge. So, you know, maybe I wouldn't do so well. But these NLP tasks would only capture a little bit of what we're possible of. They don't capture all the other things that each of us are good at. So this is where we need to think about, you know, what are some other measures outside of NLP that we could use to do these models? Because, you know, as we've used these models, as any of you have played around with, there's so many things we can do. We write stories and code and make decisions, turn them into assistants. And that stuff just isn't captured by a sentiment analysis benchmark. So how can we start doing this? How can we start taking this? Well, there's some things out there. One of the most popular ones, and you'll see all the time if you're in this space, is MMLU, which is the massive multi-language understanding. And what this is it's 57 different tasks. It's multiple choice questions in lots of different domains like history, computer science, math. So I have two of the examples here. You can think of it as just a simple kind of multiple choice test you would take, like an SAT or something like that. But this is just geared to seeing how much of the world do you really understand like that. And so this is a common benchmark that we see across large language models. Nowadays, I think it's one of the top ones you see. And so I grabbed this from papers with code, where I could see, what was the MMLU score for all of these different models. Of course, GPT-4, no surprise, is sitting up at top, far away from everybody else. But this is one way we can start understanding how much large language models do. There's some other interesting measures that I want to bring up, though. So that I don't even know how to pronounce this stuff. Hallucinations, I'm not sure. This is a benchmark that, instead of just how much history or computer science tries to get at, do you understand common sense natural language? If I give you the beginning of, and it's usually not a simple story, but it has a little bit of complication to it, can you finish the rest of the story? Can you do that natural inference here for what this dog is doing? For example, right? The woman's got a bucket and a dog, and the dog is running around trying to avoid the bath. Can you figure out what is the next logical sentence that goes along with it? And we could ask our large language models and see how well they do. And this is another common benchmark that's used to gauge these models. So I've given you a couple of these benchmarks so far. But what we can do is we can automate this a little bit. So as we get lots of these different benchmarks, there's some of these, like Big Bench is one of these, that takes 200 different tasks and puts them together into one evaluation. And I like Big Bench because it focuses on reasoning tasks. So it asks things like, how well does the LM play chess? Or, if I gave you a story, can you figure out who's the person that's the criminal in this? Or can you identify sarcasm? More complex kinds of things like that. And what I want to leave you with here is, this is from kind of a recent blog post, but I just want to point out that once we start talking about this evaluation, like I've given you a few of the common ones here, but there's a lot of different ways to evaluate these models. It could be a little bit overwhelming here, all the different tests that people are using that are out there for doing this. And so what we see is, we'll see people take all of these different evaluations and bundle them up into one harness, into one framework, and do them all. So the folks over at Stanford, this is a classic paper if people haven't seen it. It's called The Holistic Evaluation of Language Models. And they take a lot of the models, and the good thing here, the cool thing is they actually take a lot of the commercial models that are out there and try them in many different scenarios with many different metrics, and you can see how well they do. Now, the downside of this is, this is a lot of stuff, right? If you could think about the number of models, the number of tests, the number of metrics, it blows it up. The paper itself that has some of the results here is 163 pages long. And I even counted the number of words and figured out that it's longer than a Harry Potter book. So if you're trying to digest and figure this out, it's not an easy process to be able to go in and start doing this. And so this is where, it's exhausting to try to figure out which of these large language models might be the best. Now, let me try to kind of give you some inspiration and some ways that we can kind of improve this current state of affairs. One is there's evaluation harnesses, which allows you to run lots of these different tasks with just a little bit of Python code, where I can just kind of tell it exactly what are the tasks that I want to run. Here you could say, for example, I want to run, hella swag. I want to run it on this particular model. And then you can walk away, and you can even add multiple tasks. So it makes it very easy to do this. And this is a common way nowadays, is people use these evaluation harnesses to judge and see how well models work like that. So Hugging Face, for example, has a leaderboard where they've taken 4 of the popular benchmarks. So I've already talked about 2 of them. There's 2 others here that I haven't talked about. And these were picked because they were representative of, what people use to compare large language models. Gives us a little bit of insight into how these language models use. And if you go out to the website, you'll see this. I flashed it up earlier. My screenshot's old because this stuff is being updated on a regular basis. But anybody can bring their large language model over to it, run the job, get it evaluated, see how well it does and compares to other models on there. Okay, so let me take a second here and see any questions so far on this. I'm going to go into some nuances, but this is kind of the 101 basics of how people do evaluation of their models.
Hello, sir. You have told about that multi-language model processing, MLUs. So my question is does the language model have the ability to understand and generate text in multiple languages, and how far it will help the industry-based experiences?
So multiple languages is something that I haven't touched on. These tests right here, for the most part, are traditionally English only tests like that. There's other tests that do languages. And in fact, I think one of the things is we need leaderboards that better capture that for some other languages. But I think that is a piece there that a lot of the popular benchmarks now don't necessarily use like that. They're all kind of based on English. I think there's some good Chinese ones that I can't remember like that. Okay, that was part of it was multilingual. And what was the other part of your question?
If we can process the multilingual processes, then how can it will help the industry-based experiences?
How will it help the industry experiences with these models like that? Yeah. And so this is where, I was pointed to those use cases like that, because there's just so many use cases in industry where you can get these better models, whether it's for the code generation, whether it's that customer experience chatbot, whether it's question answer, all that stuff. The better your large language model, the better understandable it is, the more knowledge it has, the better responses you're going to get. I don't know how many of you have, I'm assuming everybody's played around with ChatGPT, but has anybody played around with some of the smaller open source models that there are out there? We'll steer off a little bit. Right. So if we look at the open, there's lots of these models, but there's, the GPT-2 models, there's the Kunas, the other language models. Have you all kind of played around with some of those models? Have people been exposed to that or not? No. So I'll show a little bit of stuff here. Maybe it makes sense to kind of point this out. So if you go to Hugging Face chat, for example, give it a second to load. This is something that Hugging Face built, which is kind of like a ChatGPT, but it uses open source models to do it. So you can get a sense of how good the open source is or what the differences are versus if you're used to ChatGPT. And this is useful so you understand all the different large language models out there and what are the differences among them. So I think that, there's Hugging Chat. If you go to the Hugging Face website here, there's lots of other models. I think the Falcon model is one of the latest and greatest ones that's out there that you can kind of play around with and use. And again, these are all models you can go download, use for free like that. But there's spaces here where you can go try out the Falcon chat. I can ask it, to explain semantic search. That's my usual thing. And do that. So that if you're not very familiar with this stuff, I think that's one thing. It's good to be familiar with what are the alternatives to things like ChatGPT, and all of the stuff is available out there, free to use for you as well. Is that helpful?
Yes, sir.
Yeah. Is that
S-
something you all knew, or is this like? Should I introduce you a little bit to Hugging Face, or was this already pretty familiar?
Sir, we are just like we just had an introductory to Hugging Face chat, but came to know a lot more.
Yeah. Okay. Good. So yeah, let me know if
Sir,
there's more. I can. Oh, go ahead.
there is another question in the chat. Like, will
Mhm.
this help in qualitative evaluation as well, like this LLMs?
So yeah, let's move. So far we've talked about the quantitative evaluation. So let's talk about some other ways that we can do this as well. So I'll keep going on this because I think one of the things is if you've used LMs is the quantitative itself can be a little bit difficult to do, and we ran into this problem at Hugging Face. So this happened just you can see May 26th. A couple weeks ago, Thomas Wolf, who runs the kind of the R&D department of Hugging Face, tweeted out about, hey, check out Falcon, right? It's a great new model. It beat the leaderboard. It's at the top of the leaderboard. And then somebody else was asking, like, well, wait a minute. Your leaderboard is using slightly different numbers from the numbers that when I calculated this out. Like, what's going on? How come these quantitative numbers aren't the exact same? And this is where some of the nuance comes in when you're using these language models, because how you set up your prompts, your tokenization, how you evaluate your outputs can really change how these models react. So these are three different ways to test the model that these models are tested. You have kind of the original Luther implementation, Helm, which we talked about, the Stanford Helm, and then the AI harness, which was what Hugging Face was using. Now, each of these here, the paragraphs here are prompts that we would provide the model. And then the model would then, this is a multiple choice question, give the answers at A, B, C, or D. But take a look at this carefully, right? Like how many differences do you see here between the prompts that are given? You can see there's a couple paragraphs here. There's a little bit here, a little bit here. But you should be able to pick up pretty quickly the wording isn't the exact same. And if the wording isn't exact same, that could cause the outputs to be a little bit different. Anybody that's spent a little bit of time with, doing this prompt engineering realizes this. And, in this case, for example, the Helm here has an extra space, and this one asks about, the topic line. Here we use things like words like choices and question, right? Some of these didn't ask that. So you can see that there's slight differences, and these differences could affect the score. But it's even a little bit more complicated than that, because when we talk about how we evaluate these aren't like our old-fashioned regression models that there's just a number or a category. These things output tokens, kind of words you can think about it. And so if I ask it a question, there's a lot of different tokens that it could predict. Now, if it's a multiple choice where it's A, B, C, or D, and in this case, D is the highest probability, that's the easiest case. But what happens if the model, instead of saying D, starts to give me the answer for the question? Right? Because it's multiple choice. It's just trying to, it sometimes get confused. It might not know that, oh, I'm supposed to do D. It just says, hey, what you're looking for is, in this case, the answer is zygote. Well, what happens if it does that? Should the model treat that as correct or incorrect? And you can think about this, right? You all have exams and you have instructions to follow and partial credit and things like that. Like, do you judge an exam by the first letter of how this is done, or do you look at the entire answer and see if somebody got it correct or not? Similarly, instead of just looking at that, the first word or first token, you could also evaluate these models by looking at the entire kind of output that comes out and looking at the sentence or paragraph and then rating that. And so this is where it gets really tricky when we're working with these models, figuring out and evaluating them consistently between different types of models, because they might react different to the same type of prompting. And lots of times people could spend a lot of time fine tuning prompts, getting the prompts perfect, so the outputs are stronger and look higher quality than maybe they actually are. And so it gets a little fuzzy when we're doing this because of that qualitative part of these models. And in this case, the Hugging Face has a blog post that walks through this entire story, which for me was fascinating. Part of it was when they were evaluating, even though they were evaluating on the same data set, a multiple choice data set, they were asking different questions. Was it, is it the probability of the following letter answers? Is it just kind of doing the letter? Is it looking at the entire answer and comparing that? And so this is where you could start seeing this stuff gets a little tricky to do that. And in this case, when we did these different types of measures, you get different results. And it actually changed the ranking on the leaderboard for these models, because you can see the difference here, for example, in the hardness score between the Falcon and the Llama model here drop down like that. And so this is the kind of the evaluation of these test suites that are multiple choice, right? Humans aren't evaluating this, so it's very easy to make these kind of brittle mistakes like that. There's other concerns that some of these test suites have been around for a long time. It's very possible that a large language model has already sucked in and learned all that data and kind of overfit to that. And then when you're measuring things like when you're measuring things like 200 benchmarks or 300 benchmarks, well, many of those might just average out. There might only be a few of those benchmarks which are really useful for figuring out which model is better than the others. So all these things kind of come into play with that, which is why we only use it so far.
Sir,
Yes.
there's another question, like someone is asking, if we consider the entire output and not consider it as a multiple choice answer, then eventually we have to convert it into a quantitative score, right? So doesn't that beat the whole point then?
Well, I think so we do turn it into a quantitative score at the end, but I think the question is do we care more about the full answer that the model can explain exactly what it's doing with like a full answer versus a letter? Because a lot of times the way we'll use this model is, for most things, we don't use it to give us a letter like A, B, C, or D. We really want the model to be able to explain something in kind of this nice sentence in a longer form. So it could be more useful to evaluate the models in the longer form. Now, in the end, you're right, because this is an automated evaluation suite, we're going to convert that into a multiple choice answer and then convert that into a quantitative score. But for some of these things, it's still, how we evaluate it is, do we evaluate it just based on the letter or the entire sentence? I don't know if that got to what that question was.
Yes, sir, he got it.
Is okay? Okay. I mean, and look, a lot of this, I will point out, there's no good hard answers to a lot of this stuff. We're just figuring it out as we go through. I mean, the folks in NLP have struggled with this over the last couple of years, where they've noticed in traditional NLP tasks like summarization, there's a lot of variation that depending on how you judge things and what's going on. Now, as these models grow and as we have more and more varied tasks, this is something that we're all struggling with, is how we kind of evaluate. So one way is that very quantitative, like let's just rank them this way. Another is, let's just compete these models against each other. And so the folks over at LMSys have these battles that they do against the models and see how well they do. And it might be easier just to kind of show you what they do. Did I have that? I thought I had it open. So they have a chatbot arena. And the way it works is two models compete against each other. And in this case, I've given both models a query. I should probably use something more interesting. They're both very good at this nowadays. But I've given it a query, but I can look at both outputs side by side here and then decide which one is better. And having that human interpretation, that human subjective view in there. And because this qualitative is very useful in things like this, because there's lots of pieces that we might pick up that a quantitative test might not pick up like that. We understand, you know, is it accurate? Is it harmful? Is it fair? You know, how well is it summarized? Is it clear to people? Like there's a lot of nuance like that that people pick up all the time that isn't necessarily easy to quantify. But you go through this and you just tell it which is better. And the approach here is, if you're used to chess and kind of ELO rankings here, is they take that similar type of approach with the leaderboard. So it's very easy to kind of judge which model works better than others. And you can see here again, GPT-4 and Claude are at the top of this. But I think this is an interesting way of kind of measuring the models. And what I like about this approach is it really captures that human subjectivity part. But with the ELO ratings, you can also introduce a new model, and it doesn't take, you know, a long time for you to quickly get a sense of like how good this model is doing or not doing compared to everything else. Does it come in and start instantly beating all the other models, or, you know, is it somewhere in the middle like that as well? So I think this type of approach we're going to see more and more, because, you know, inside enterprises, inside actual use cases of this, it's useful to have humans in the loop to evaluate what's going on with the outputs. So I can see a lot of scenarios where people will build these types of competition arenas, gamify them, and try to have their employees at a company do that. So, you know, over your lunch hour, you rank 4 or 5 different things. And if you have all the people in the company doing that, you can have a massive amount of data that you'll have that helps you evaluate, helps you figure out which of these models are better, and helps improve, what are the limitations of models, all that kind of stuff like that, that otherwise your quantitative metrics might miss. Okay. All right. So those are, that's the head-to-head leaderboards. Related to this is human evaluation, but sometimes you can have direct human evaluation of these models where we just give the outputs to humans and have them rank them. One thing is we should always keep in mind is humans can be much more expensive, which is why folks try to use these automated ways. Depending on how you set things up, there can also be a lot of variation when you're using humans to evaluate things. And often, sometimes you need like 2 or 3 humans looking at the same thing to be able to figure out, and throw out the variation that might occur like that. So that's another piece here. And then the final one that I think is interesting is this algorithmic evaluation. How we can use other models, other systems to help us evaluate this. And you see this very common with people using GPT-4 or GPT-3 or one of the other LLMs to evaluate how good the responses are. And this struck me as really weird. Like, wait, we're using one model to evaluate another model? Like, how would this work like that? But you know what? It's worked pretty reliably. I see a lot of different scenarios where people will ask a model and say, well, this model gave this output. Hey, second model, do you think this is a fair output? Do you think this is a well-reasoned output? Do you think it's factually accurate? And ask lots of questions like that. And this paper came out about a couple months ago, and I'm looking for more on this. But it compared evaluating GPT-4 to humans, and it found out that, the GPT-4 does a pretty good job. I mean, it correlates well with how human quality judgments of this. Now, there's some nuances, and it's sensitive to instructions and how you set up the prompts like that. These metrics also favor kind of the computer generated metrics, favor the computer generated text, but it's a very credible way, especially because you can do GPT-4 evaluation for maybe a couple hundred or a couple $1,000, where humans might cost 10, 50, 100 times that amount for that same type of evaluation as well. All right. So I'm going to switch gears and talk about hallucinations, but let me see, is there anything else um, I should talk about in terms of evaluating the models? We hit the qualitative point, hopefully. Anything else people are thinking about?
I have a question
Mhm.
regarding the biasing part.
Yeah,
So when I use the chat GPT also, I see a lot of bias based on the region of the data. So how people in industry are identifying the bias in this? Because until they do prompt engineering or give such type of prompts manually, they don't know whether biasing, which type of biasing is there in the model or not. So
yeah.
I would, I
So
would like, thank
yeah, no, that's a great question, and so a little bit of it depends on the bias. I'm trying to get to the slide here that has this. Um, so one of the things you'll often see in these evaluation harnesses is you'll see some benchmarks around, for example, toxicity. You know how biased, how harmful it is. You'll see here's a benchmark around truthful. So for some of these things, depending on what you mean by bias, we do have good test suites that we can do. The second thing that comes into, which I'm going to talk about here in a second, is the hallucinations, how the models just make up stuff and how that factors in as well. All right.
yes, yes, I understood. I
Mhm.
mean, the biasing in the like a same answer which a model gives can be interpreted differently by different parts of the world, right? I
Yeah.
mean, that types of bias also.
Yeah. I mean, and some of the stuff like there, you're right. There's that subjectivity to it. So it's just, can we create an objective test so we can find some way to automate, identifying that type of stuff? Is it, for example, like these hallucinations, something that's part of the model, but maybe if we switch models, another model might not be as susceptible to that bias. And so we just need to try, maybe an improved model like that. So this is one of the classic problems that we have with these models is that they make up stuff, they hallucinate, whatever you want to call it, right, untrue information like that. Hopefully you're all quite aware of this. This is like the most basics of using these models is knowing that they put out and can make up lots of different facts here. But so a common thing that comes up is, how do we deal with these hallucinations like that when we're evaluating the models? So it's a little bit slightly different than evaluating LLMs, but I get asked this all the time, so I just wanted to at least include a few slides. I'll see maybe later it'll be a separate talk or something along those ways, like that. And right, these mistakes happen all the times with these models like that, and it makes it very hard to evaluate. So I don't have the answers for this, but I think some of the things I want to point out with this is one reason we have problems with these models doing this type of hallucination or facts is there's been a huge movement towards fine tuning language models with imitation data. And so what happens is people have used GPT-4, for example, to create large amounts of chats. They use those chats to then train a smaller language model. That smaller language model does a good job of imitating and getting the style of that because it has lots of examples. But one thing that people are noticing is that smaller model is more likely to hallucinate. Like on the face of it, it looks like and sounds like GPT-4, but if you actually push a little bit and ask it deeper questions, it falls apart. And it's simply because that smaller language model doesn't have as much world knowledge. It doesn't know as much. And so it might seem to imitate GPT-4, but it's not GPT-4. And there's a real worry here that the models might sound very impressive, but don't actually give you really accurate information. And that can be heightened with this kind of process of imitation. And so that's one concern with this. And one way to think about improving the factual basis of this model is using models that have more knowledge inside them instead of just using this imitation approach. Now, there's a lot of different practical things we can do. I'm not going to go through them all. Here's a great blog post that I found that has a number of the common things that I recommend to kind of my customers to do, from settings that we have on the model, things like temperature that we can use, using an external knowledge base. So not relying on the model for facts, but pulling from some other source and then just using the model to rearrange the language as well. Things like self-consistency and voting, where we have multiple different LLMs coming in, and then we aggregate those, right? Ensembles, long history of machine learning, they work really well. GPT-4 uses ensembles. That's a great approach to use. So number of things like techniques like we can do like that, but hallucinations still are an endemic part of using these models like that. I saw this package recently. I haven't had much chance to play with, but this, what it does is you can run this package and it measures how well your model is doing on kind of a factuality based and a relevance base. And what it does is it literally uses GPT-4 where it passes over your examples and it asks GPT-4, is this factual or not? Is it relevant or not? And it gets a score. And what this is really useful for is if I'm switching between two different models, I can run this and see which of the results are more factual than others like that. So this is that example again of like using another external model as a way to do that. But since you can automate this, it can be an easy measure to see as you're comparing different LLMs, do you notice a difference? Do we see all of a sudden see one seem like it's less factually accurate than the others? It's not actually measuring whether or not it's factually accurate. It's just GPT-4's interpretation of that factual accuracy. So I should mention that. Besides that, there's a ton of different tools coming because a lot of people are dealing with like the guardrails, the issues with these models. There's, I think, like 2 packages called guardrails that are out there. I saw TrueLens yesterday do a webinar. All of these things are tools out there to help evaluate the outputs of these models. Simply, the issues of bias, the toxicity, all that stuff. People are trying to see, is there a third tool that I can bring in to help monitor that and to kind of set up the guardrails with language models. So that's another approach people are taking to kind of dealing with the outputs and the hallucinations of these models. I should put the links and things like that in there like that. So hopefully now, I've given you a bit of knowledge on kind of all these different evaluation approaches and kind of some of the techniques that you can kind of deal with hallucinations as well.
Rajiv,
Yeah.
There's a question like other than GPT-4, there are any open source models that can be used for the same evaluation?
Yeah, so I have not dug into Ragus. It's literally like a couple of weeks old out there. There's no reason why you could not set it up, and it's open source. No reason you couldn't use another model instead of GPT-4 to do that. I just haven't dug into it. The one thing is GPT-4 is the strongest model in terms of being able to ascertain these things. So there might be a drop in performance, but yeah, absolutely check it out. If you do, let me know how it goes. I'm always trying to understand all this stuff like that. So
actually, I too have a question, Rajiv.
Yes.
There are a lot like the competition that is going in the leaderboard regarding the best large language model. So is there any parameters set to consider the ethical considerations of the LLMs?
Now, can you tell me a little bit more, like what you're thinking about in terms of ethical considerations?
We are having the GPT-4s and ChatGPT, and there's a lot of mistake. Like we can say there are a lot of mistakes regarding the ethical considerations. Like the model is trained on the open source data beforehand. So I want to ask: is there any like support system, or is there any community who is working towards the ethical LLM, so that the
Yeah. So, for example, there's a lot of folks at Hugging Face focused on the ethics considerations around these models, and they publish quite a bit. I think there's a recent newsletter that they the blog. So I'm going to answer this question in a number of different ways. So I think one thing is we have a big community inside Hugging Face that thinks a lot actively about the bias and ethics issues. So I would urge you to, take a look at the newsletter, take a look at the resources there. We spend a lot of time writing papers about these issues. Now, for the specific thing you're asking about, one question is this something that's you can quantify or put inside a test data set like that? This open leaderboard here is run on a handful of benchmarks, but all of this stuff is open source. How you run this, you could very easily build 2 or 3 reference benchmarks, evaluations that you could then run against multiple models and just judge, is there ethics, is there bias issues with that as well, like that.
Thank you.
Mhm.
There's another questions, Rajiv. Like
keep them coming now. Yes.
So, like, where does you see the role of LLMs in business and enterprise solution in your future?
Right now is the hottest time ever I've seen for these LLMs. I mean, most of the companies that I work with, their board of directors, their leadership, they all want to see generative AI. They get that generative AI is a big difference maker. They want it. Now, it's still early on. Very few companies have actually put things into production. They're all out there looking for people to hire that know these skills and can apply these skills. And I think over the next year or so, you'll see lots of these different things being produced and put out there like that. So yeah, a tremendous demand. The use cases that I see that work the best, kind of as we talked about, is that customer support, customer experience, document search, code generation. Those are things that I see quite commonly in the space already.
Okay. Yeah. Thank you.
Yes.
Rajiv, another questions related to that ethical concerns only. Like,
Mm-hmm.
what measures are in place today to mitigate the potential risk associated with the use of LLM, like such as generation of the harmful text or inappropriate contents?
Yeah, and so there's a lot of things when it comes to ethics and the risks of these models like that. So I think we talked narrowly about one aspect of it, the hallucinations. And right now, there aren't a lot of protections for the hallucinations and the models making mistakes like that. So this is why we urge people to always have a human in the loop and check the facts of it. Kind of where there's been some guardrails is for some of these models. So especially like the chat GPTs have tuned these models so they're less biased. So if you ask it a question about race or gender or something that's inappropriate, the models won't give you an answer or will do their best to try to avoid it. So I think that's where we see some of the guardrails at this far. It's hard on the factual basis, but there's a lot of questions around ethics and risks of these models. For example, what's the data that's being used to train these models? OpenAI just came under some lawsuits recently to kind of do that. Most of the companies have not been very transparent about what's being used to train these models. Hugging Face, when it's built its models, has been very transparent and told people exactly what it is. There's concerns about the outputs of these models. Could they infringe upon existing copyrights? Am I creating images that's already in Getty's image data set? So yeah, there's a whole host. I could do a whole hour-long talk on all the risks associated with these models. But yes, there's a lot of good stuff.
Thank you, Rajiv.
Yes.
Is there any Rajiv? There is another questions by our crowd.
Mm-hmm.
One of them is asking, like, has any Hugging Face LLM been evaluated against the specific task or data sets relevant to any particular use case? And if yes, then what were the results?
So, so the Hugging Face models that are out there on the hub. So let me back up. So Hugging Face has a hub which has lots of different models that are out there. So if I go over and I see here's the Falcon model here, but if I just look at the text generation models that are out there, there's lots of different models that are hosted at Hugging Face that people use. Now, Hugging Face worked with Big Science, which was a consortium of about 1,000 different academics that built a model, Bloom. So that's one that Hugging Face has been kind of indirectly involved in. There's other models like StarCoder, which Hugging Face recently released, or SantaCoder, which is focused on code generation tasks like the autocomplete of Python. Oh, wait, it's actually StarCoder. The SantaCoder is something different. And so there's some models like that Hugging Face developed. A lot of it is the larger open source community, but there's a lot of benchmarks out there, lots of use cases studies where people have started using these models overall and put them into kind of different scenarios like that. So I don't have like one direct paper or something like that, but if you look around, you'll see a number of these open source models. The Llama models, for example, are very popular, and you'll see a lot of literature in the academic world about those models.
Yeah, thank you, Rajiv. Uh,
Mhm.
I guess Nikhil has a questions. Yeah, Nikhil, you can go.
Yes, I mean, there's a lot of them. So if you take a look at something like the Falcon model that's out there, you'll see the model cards here will provide some documentation for how to use them. They'll often provide kind of a quick script to be able to use them like that. There's a lot of people out there that have put together YouTube tutorials, that have put together their own, collab tutorials like that. So if you look around, if you just Google search, you'll see that there's a ton of results. One of my colleagues, Philip, has put together lots of tutorials. He's very good about every week or so putting together a tutorial using these types of Hugging Face models. And so that's another good resource if you want. So, for example, you can see he's been doing a bunch on AWS lately, but you can run these in any type of environment as well. Yep. And I mean, if you're interested in large language models, um, that's one thing. One thing I will point out: transformers, the basics of all these different technologies. Hugging Face does have a course that you can take around this. So if we go over here to learn, there's a course just on NLP that introduces you to the transformers library, walks you through kind of using it for the first time. We've just added an audio course as well. So this is a great recommendation for people that want to get a little bit deeper into understanding what transformers are, what an encoder is, what are tokenizers, all those different pieces like that. And it's all available for free. You can do it on your own pace like that.
Thank you, Rajiv. Actually, there's a lot of questions from the crowd regarding. Actually, they want to ask like, what should be their approach to join such big tech companies like Hugging Face and H2O.ai? How do they build themselves to compete in the AI world, and what should be their learning processes?
Yeah, I don't know if I have all the answers for how to join those companies. I think the things that we look for smart people, people who are creative, people who have solved interesting challenges. So I think this is one I always recommend to people to have a portfolio of projects that you've created. And especially just don't do the same project that everybody else has done with the Kaggle data set like that. Like the more interesting, the more varied you can make the project to stand out from the crowd, the better. I think showing people that you've applied these skills is really important. Like that is, one thing I always recommend. And you also have to be realistic. Like Hugging Face has 160 people in there, right? We hire 10 or 20 people a year like that. It's a very difficult job to get. H2O is the same way. I worked at DataRobot for many years, and I remember at DataRobot, the HR person saying that it was easier to get into Harvard than it was to get a job at DataRobot. And so you can't expect that right out of university or something you'll work at something like that. But it's one of those, you work hard, you prove yourself, you kind of solve problems, whether it's open source, whether it's at another company like that, you're able to see that you can kind of move up after that.
Thanks a lot, Rajiv.
Yeah, and feel free to kind of reach out to me on LinkedIn if you have more questions. Again, there's all the social media I'm on as well.
So I guess hopefully the session is ended. So on behalf of ML4 and IIT Raikula, I would like to extend my sincerest gratitude for your exceptional talk on identifying these useful large language models. And Rajiv, surely your expertise and insightful presentation will left a lasting impact on all the attendees. And we are truly grateful for the knowledge and expertise you shared with us today. So thanks a lot for coming and joining us. We hope to
Thank you all
collaborate
for
with you
having
in
me.
future.
Yes, thank you all.
Hello, one second. I am sorry to interrupt you.
Mm-hmm.
Hi, Rajiv. I'm Marchandra this side.
Yeah.
Yeah, I work at Siemens as a resource engineer.
Mm-hmm.
Yeah, think we just a quick recap. Have you covered the inference point of view from evaluation perspective or the evaluation of the output?
So I focused more on the evaluation of the outputs. Are you thinking like different inference speeds and different technical approaches we have for getting inference out of these models.
Yeah, yeah, yeah.
Yeah, I didn't really talk. I talked about that. My quick recommendation for that is Hugging Face has created the text generation inference open source package for working with large language models, and this is where I've been pointing most of my kind of customers and prospects to.
Okay, yeah, yeah. Like the majority of question I have, yeah. I think you must be familiar with the GGML library, right? The Judge, I think, come up with Llama CPP, the Whisper CPP implementation, right?
Mhm.
And it's been able, like, he is able to run it on 7 billion models on Mac M1, I think, yeah.
Yep.
So how do you see that possibility running any LLM on, let's say, edge devices? For now, let's say mobile devices and maybe gradually on Raspberry Pis and stuff. Basically on edge devices.
Look, there's been a ton of interesting innovation. The GGML, taking the C version, figuring out how to make it efficient, run all these models. I think it's a great example of kind of what open source can do once things get out in the wild and lots of people can work on them. There's still some things to think about though in terms of trade-offs. Like you don't get something for nothing. Typically, when we're doing this quantization, we're removing pieces of information. We're compressing that model down. And so, well, yes, technically it can run on something that's smaller, but there can also be some of the information that's lost. So that's where, like, the different things we were talking about, running the evaluation metrics, you need to do that as you, for example, do that quantization. As you reduce, you distill down and go to a different model. You'll need to still run those same tests to make sure that you haven't lost quality of those results like that. So everything I talked about evaluation is important as you're thinking about doing exactly what you're doing, is reducing the model, trying to make it more efficient like that. I mean, we all want to get to the place where we can run a GPT-4 on our phone. I just think it's going to take us a little while before we figure all that out.
Yeah, like basically, every quantization comes with trade-off, right? Like you either, trade off with your token quality, or you either trade off with your speed or inference time, right?
Mm-hmm.
Yeah, go ahead.
I just want to point out to everybody, like, that's good old-fashioned engineering. Like all these problems you'll deal with in life, there's always trade-offs like that. So yes.
Mm-hmm. Have you seen any recent development in medical domain? This question is a bit personal to me because I work in the same domain. So,
I mean, I think that in the medical domain, the biggest thing is you're starting to see some language models that are built for the medical domain, and it's been happening for a long time in the medical domain. For example, like BioBert is a language model that's just been trained on healthcare. Google is going to release MedPalm or make that available, which is their Palm version, which has been trained on medical. I have lots of healthcare customers that train their own, that have massive amounts of data. So they build their own large language models just trained on healthcare data as well. So I think that's the biggest piece there. But healthcare, since it has so much documents, it's like, especially in the US, like they're so rich of corpus, and it's a pain for people to work, for nurses, doctors, all these people to have to do this stuff. Like introducing LLMs to help summarize, to condense, to structure, to ask questions is very useful. And so you'll see quite a bit of uses inside healthcare.
Yeah, like point is, if you dive into medical NLP, right? Point of the factual correctness, one thing, right? And how well you, kind of detain your context. That matters a lot. For example, let's talk about in diagnosis system, right? Your entire patient log, your entire patient demographics plays a key role, right? So if you go about building any general GPT, any general language model, yes, building and resources are fine. But when you take into production level, you need to get approval from FDA and everything, right? So how do you see that feature? Because we can develop any model that can generate some data points, and you can say, we have some evaluation metric and it's giving some evaluation metrics. Right? How do you explain it to FDA?
Yeah, and this is where, like, right now, every solution I see is human in the loop. So it does it, but we're still going to have a doctor, nurse, or somebody else double check the results, because just the risk of hallucinations is so great, and the chance of hallucinations is so great, and the risk of damage or hurting somebody is so high that it's not worth taking the risk. For, if you're doing code completion for your JavaScript code, it's okay if it makes an error, because it's not going to cause the end of the world, right? You're going to know it doesn't compile, it doesn't run. But it's in the healthcare industry, right? It's different like that. So
yeah, I can mess with patients. So.
Yeah.
Okay. Yeah.
All
That's
right.
it was from me. I'm good to have you.
Okay. Yeah. No, this is good. I have to run now, but no, this has been great.
Thank
Thanks,
you,
everyone.
Rajiv.
Thank you all.
Thanks a lot.